In this video, I will explain the diffraction minimum condition. A plane wave hits the single slit of width A. From this point to this point, it is A. According to Huygens principle, each point in this slit acts like a secondary light source. And the light coming from here hits this screen and they interfere constructively because all these are in phase. They are in phase, and which all these constructively interfere and then gives a central maximum. Now we are going to consider the minimum on both sides. This is the first order minimum. We are going to get the condition for first order minimum. So take point P1 on the screen, and we are going to consider two rays coming from top of the slit and from the mid of the slit. Okay, so for this point to be dark, the path difference between R1 and R2 should be at least lambda by 2. Then only the two waves interfere destructively and gives a dark fringe. So if you want to find out the path length difference between two rays, you have to draw a line, perpendicular line like this. This is a perpendicular line. And now if you calculate sine theta from this right angle triangle, that is, this is the right angle triangle and this is theta, and if you find sine theta, and this length is, now we know it is a lambda by 2, lambda by 2. So if you find sine theta, and then you will see sine theta equals opposite side, that is lambda by 2 divided by a by 2, that is a hypotenuse. So a by 2 sine theta equals lambda by 2, which gives you a sine theta equals lambda. So from here we can get the condition for the first minimum. A sine theta should be equal to lambda, which means if you consider the entire width of the slit, that is the A, the path difference is lambda. Okay. Now, suppose if you divide the slit into four halves, A by 4, A by 4, A by 4, A by 4, and now you take the difference, path difference between any two rays, and they also will give a path length difference lambda by 2 to have a dark fringe. So one particular A by 4, I mean like from this part of the slit will give you a path length difference is lambda by 2. So similarly, four parts of this slit gives you overall 2 lambda difference. Okay, if you consider the entire slit with A, then the path length difference is 2 lambda. So this will give you second minimum. This is the first minimum and this one is the second minimum. Okay, so like this we can find out the position of the dark fringe by this condition. In general, we can write A sine theta equals n lambda. N actually goes from 1, 2, 3, okay, and this gives the condition for dark fringes. Thank you.